Okay, here we go with section 4 of chapter 3. Chapter 3, remember, was on matter. Section 4, elements and compounds. Our objectives: distinguish between elements and compounds, describe the organization of elements in the periodic table, explain how all compounds obey the law of definite and multiple proportions. Review vocabulary. Proportion, the relation of one part to another or to the whole part with respect to quantity. New vocabulary. Let's try that again. New vocabulary. Element, periodic table, compound, law of definite proportions, percent by mass, law of multiple proportions. And the main idea: a compound is a combination of two or more elements. Okay, so let's review what an element is. I know you've talked about this. An element is a pure substance that cannot be separated into simpler substances by any physical or chemical means. If I had an atom of hydrogen, I could not break it down into any smaller part. Okay, element cannot be broken down. There are 92 elements that occur naturally on the earth, a lot of them in the crust. Each element has a unique name. It is either a 1 or 2 letter, or the unknowns have 3 letter symbols, always with the first one capitalized. And then they are all organized in what's called the periodic table. This organizes the elements called periods, or vertical columns called groups or families. Here is an example of one element. This is sodium. Okay, it has its chemical symbol is Na, 1 capital letter and 1 lowercase letter. It has the number 11, which is its atomic number, and 22.9897698. That is its atomic mass, and we will study those as we get into the periodic table. Okay, so an element cannot be broken down into anything smaller. A compound, on the other hand, is made up of 2 or more elements that are chemically combined. And we have used many compounds already in class. Most of the matter in the universe exists as compounds. You see very few elements. Table salt is one, what you put on your French fries at McDonald's. Okay? Water is a very typical compound that we use. We just did a lab with silver nitrate. So we've used a lot of compounds. Remember, elements can never be broken down. Compounds, on the other hand, can be broken down by physical means. So remember the lab that we just did. We did copper wire was added to silver nitrate. Remember, the copper combined with the nitrate to make copper nitrate and left the silver by itself. So compounds can be broken down, elements cannot be. Here they're just showing you a picture representation of some chemical compounds. Hydrogen, water, you have 2 hydrogens and 1 oxygen. Ammonia, you have 1 nitrogen and 3 hydrogens. Carbon dioxide, you have this little bitty carbon in the middle with 2 bigger oxygens on the side. And hydrogen peroxide, you have 1 hydrogen attached to an oxygen, oxygen attached to a hydrogen. Okay, this is one of my favorite things that we get to do in class. This is called electrolysis. And what you do is you take water and you break it down into hydrogen and oxygen. But remember, we cannot break it down any further than hydrogen or oxygen. So you're literally taking the water out of the sink, out of your tap, and you are separating it into its elements, hydrogen and oxygen. Okay, the properties of a compound are different from its component elements. Okay, so think about that as we go through this chart. If you have a piece of matter, you have to determine whether it's a mixture or a pure substance. Okay? We've talked about mixtures. If it's a mixture, it's either a heterogeneous mixture or a homogeneous mixture. Hetero means different. There are different parts in there. So dirt, blood, milk, all of those are made up of different substances. Homogeneous, it's all mixed together. It's all the same. It's all one substance. So you have lemonade, gasoline, and steel. It's difficult to pull the parts out. Heterogeneous, remember my favorite one is the Supreme Pizza, where you can pull the pepperonis or the mushrooms off if you don't like them. Okay, so if you go to the other side, we know we don't have a mixture, but we have a pure substance. It's either an element that cannot be broken down into any smaller part, or it's a compound, which is a combination of elements. Notice this arrow, chemical change. So there is a chemical change that's going on when the elements combine to make a compound, or compounds are broken apart into their elements. So when we did electrolysis on that previous slide, we are chemically changing the water into its two elements. Okay, you guys studied this in that virtual lab. The law of definite proportion states that a compound is always composed of the same elements in the same proportion by mass, no matter how large or how small the sample. Law of definite proportion. So if I have water, and I have 2 drops of water sitting on the counter, I still have 2 hydrogens to every 1 oxygen. If I have 2 liters of water, I still have 2 hydrogen atoms to every 1 atom of oxygen. So 2 to 1. H2O, 2 hydrogens to 1 oxygen. Okay, the relative amounts are expressed as percent by mass. The ratio of the mass of each element to the total mass of the compound expressed as a percentage. And you did this in the virtual lab as well. So the mass of the element divided by the mass of the compound times 100 gives you the percentage. So let's look at some examples in this table here. Okay, so if we have sugar, okay, we have sugar. Sugar is made up of carbon, hydrogen, and oxygen. So we have 8.44 grams of carbon in our 20 grams of sugar. So if we do the math and multiply through, we have 42.2% carbon. If we have 1.30 grams of hydrogen, we know that it makes up 6.5% of the mass. If we have oxygen at 10.26 grams, we know that it is 51.3% oxygen. Remember, all of these percents need to add up to 100. Okay? Law of multiple proportion states that when different compounds are formed by a combination of the same elements, different masses of one element combine with the same relative mass of the other element in whole number ratios. Okay, so if you look at this, we know we have H2O2. Okay, we know we have 2 atoms of hydrogen, and we have 2 atoms of oxygen. Okay, this is hydrogen peroxide. This is water. You have 2 hydrogens and 1 oxygen. Okay. Copper chloride is another example. Copper 1, that tells you that there's 1 copper combining with the chloride. Here you have, this is actually the charge, so you have a different copper, so copper 2 is combining with the chloride. Okay, law of multiple proportions. Okay, so data analysis of 2 copper compounds. So compound 1 has 64.2% copper, 35.8% chloride. You can see the masses here. They have calculated the masses. So what's the mass ratio? Okay, then you do your math. You take the copper divided by the chloride. Okay, and your answer is? Yay! Yay! All right, that's the end of chapter 3.